From numbers to data science, evolution of mathematical thinking. So, if we talk about the evolution of mathematical thinking, it represents a shift from measuring objects to measuring relationships and finally to measuring entire systems. Because we started the mathematical journey by measuring objects, then we started looking into measuring relationships, and now we are measuring the entire systems. So, this progression is what allowed us to move from simple counting to building artificial intelligence. So, if we talk about the evolution of mathematical thinking, it started with the step one, the numbers, the scalars. So, it was all about measuring a single isolated quantity at a specific moment, like measuring the coordinates of a point in space or the temperature. Now, the limitation of this approach is that single isolated quantity, a number, it has a magnitude but no direction or context. It is a point in a zero dimensional space because if we are talking about single isolated numbers, they are representing just the magnitude, no direction or context. For example, if I talk about the temperature is 32 degree Celsius. So we are measuring the temperature with a single isolated quantity 32. Now this number is giving us an idea about how hot the object is, but it tells you nothing about the wind, humidity, or how the weather is changing. So that is what the numbers. So we started our mathematical journey, the mathematical thinking by measuring objects. And to measure objects, we just dealt with numbers, the scalars, single isolated quantities. Then we came across equations, the variables. So equation means dealing with the relationship between the numbers. So equations, the concept is the rule or the relationship between the quantities. So identifying a rule or a relationship between two or more quantities is what the equation is. Then we started measuring the relationships, the rule or the relationship between two or more quantities. Now the limitation of this step, the equations, is equations usually solve for a static unknown. They describe a balance like a scale. So for static scenarios, equations are well and good for static unknowns. But what if we are trying to analyze a dynamic system wherein the relationship is also changing? If the relationship is static, we can make use of equations to deal with it. But if the parameters are changing, then we will be needing something called as calculus. We have to measure the change. So at that time, there was no calculus. So that is the limitation of equations. It is good for solving static unknowns. So if the quantities are not changing with time, then equations are good. But if the quantities are changing with time, then these equations will no longer be valid. Like if we talk about an example, like 2x plus 3 is equals to 7. Let us suppose this is a linear equation. Now, in order to satisfy this, what should be the value of x? If x is 2, then this equation is satisfied. So we are discussing the evolution of mathematical thinking, and the step 3 in the evolution is the vectors, which are basically the list of numbers. Now let us understand the core concept of vectors. So grouping multiple related quantities into a single mathematical object. So the core concept of vector is basically grouping related quantities into a single mathematical object. This is where geometry enters the picture. This is where geometry enters the picture. So here we are treating data as geometry. Here we are talking about pattern. So In vector, what we do, we group related quantities into a single mathematical object. And what benefit we get is a vector represents state or direction in a multi-dimensional space. So if we talk about vectors, vectors contains numbers as well as it also represents a direction or a state in a multi-dimensional space. So that's the power of vector. So instead of just temperature, a weather station uses a vector. And if the weather station uses a vector, it will make use of a mathematical object like this, which will contain information about the temperature, the wind, the humidity. So that's the importance of vector. So now the idea is very clear that with vector, we can group related quantities into a single mathematical object. So here we have a weather information of a particular geographical coordinate. So rather than just specifying the temperature, we are making use of a vector which is holding the temperature, the humidity, and the wind. Now the weather is a single point in 3D space. So vector, so that is what the vector is. So now we can imagine or we can realize the evolution of mathematical thinking, like how we started with the numbers, the single isolated quantities, to vectors, which are group of related quantities, like grouping of related quantities into a single mathematical object. Then in this evolution, we have matrices or the grids. Now let us understand the concept of it. So collection of vectors is the matrices. So a matrix does not just show a state, rather it shows a transformation or an entire data set. So collection of vectors. So a vector is an information about a single point, but matrix can represent the entire region, wherein the column can be individual points. Or let us suppose if we talk about weekly weather. So what was the weather on Monday, Tuesday, Wednesday? So matrix can represent the entire information, the entire data set. And with matrix, we can see the relationship also, like how the trends, the temperature is changing with days. So that is what matrix. So matrix is basically collection of vectors. Now, if we talk about the power of matrix, like what advantage we get, if a vector is a snapshot, a matrix is a photo album or a map. So the idea is that vector you can treat it to be snapshots, and if we collect all that snapshots, the collection of all those snapshots will be a photo album, and that is what a matrix is. It allows us to perform linear transformations, such as rotating an image or projecting data from 3D down to 2D. Now, in this evolution of mathematical thinking, we have the step 5, that is the data science. So, data science is the massive systems. So, let us understand the concept first. So, using matrices so large that they efficiently describe reality. So, in data science, what we do is that we measure the entire systems. So we make use of massive matrices containing billions of rows and columns describing the reality. So in data science, we deal with massive matrices like huge data sets describing the reality. We process it to measure the entire systems. So data science is all about measuring the entire systems, measuring the reality, analyzing the massive systems. So we make use of massive matrices, massive data sets, huge data sets containing billions of rows and columns, which describes the reality. Now, what is the power of data science? Like what benefits we get? So data science is like linear algebra at scale. We stop looking at individual numbers and start looking at the topology, the shape of the data. If we talk about examples, So we have an interesting example of LLMs, large language models, for example, ChatGPT. So here, language as a matrix of word relationships. So large language models, they treat the entire human language as a matrix of word relationships. Similarly, if we talk about genomics, it represents the human genome as a matrix to identify disease markers. And if we talk about social physics, mapping every human connection on Earth to predict economic trends. So, when we talk about data science, we are talking about linear algebra at scale, wherein we are talking about huge data sets like large language model. It makes use of the entire human language. So, we have a matrix which is representing the entire human language, the word relationships of the entire human language. So, linear algebra at scale. And with this, we can measure the entire systems. We can analyze the entire systems. So now we can see the fundamental shift. Like we started our mathematical thinking by asking questions like what is the value, to asking question like what is a pattern. Because now in the modern world, mathematical thinking is not about measuring individual quantities. Rather, it is about measuring the entire system, analyzing the entire system. So now we are asking questions like what is the pattern rather than what is the value. And here linear algebra plays a very big role. Linear algebra, it allows, so linear algebra is the only branch of mathematics that allows us to compute these patterns across millions of variables at once. So using linear algebra, we can compute patterns across millions of variables at once.